All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing the optimization module. Let's have a look at what we went over tonight. Now, last night, you remember we went over our state space landscape, and we went over the possibility of getting large between our local maximum and local minimum, and not being able to move out of it because we were using our hill climbing function. We're gonna pick up where we left off last night. So if we want some chance of being able to find a global maximum, we can't always make the good moves. We have to sometimes make bad moves and allow ourselves to make a move in a direction that actually seems like it makes our situation worse in the present, such that later we can find our way up to our global maximum. And once we get to our global maximum, then we don't want to be moving to states that are worse than our current state. And so this is where this metaphor for annealing starts to come in, where we want to start making more random moves and over time start to make fewer of those random moves based on a particular temperature schedule. Now, this is a simulated annealing definition right here. Let's go over that. So it says that early on, higher temperature, more likely to accept neighbors that are worse than current state. And later on, lower temperature, less likely to accept neighbors that are worse than current state. So what that means is when the temperature is higher, our program is more likely to accept neighbors that are worse in the current state. Later on, when the temperature is lower, it's less likely that we accept neighbors that are in worse than current states. So high temperatures mean we can move freely. Lower temperatures mean that we're pretty much locked in place. That's what we went over tonight, and we pretty much just went over a lot of that and how to actually implement that, and actually did some pseudo code down here. Let me see if I can get to it and show you. So we actually did some pseudo code here for simulated annealing. I'm not going to go over it all the way right now, but just give you a look at it. If you want to take a peek at it, you can. But yep, we're going to keep moving forward, and I'll keep you guys posted. For now, this is the Python Poppy. You guys stay Gucci.